Hey guys, welcome back to my channel. Hope all of you are doing absolutely great and staying safe. So now in this particular video, we will be covering very basics of linear regression models. So now without any further ado, let's get started. Now first of all, let's understand what do you mean by regression. As we discussed in our previous video, whenever our target variable that we need to predict is a continuous variable, then such kind of problems are known as regression problem. Now, in linear regression problem, our dependent variable is continuous in nature as well as it is linearly related with your independent variables. As you can see in this particular example, let's say I want to predict the price of a house, right? Using the square foot area of that particular house. Now, as the area increase, the price of my house will also increase. So these two variables are linearly related with each other. Now there are mainly two type of linear regression. One is simple linear regression and another is multiple linear regression. In simple linear regression, we will use only one independent variable to predict our dependent variable. So x is our one independent variable with the help of which we are predicting our y variable, that is our target variable. So for example, in this particular scenario, we have area as our independent variable with the help of which we are predicting price, that is our target variable, right? So x will be area here and y will be your price. Now, what happens in multiple linear regression is that we use more than one independent variable to predict our dependent variable. So, if I'll consider this same example, let's say along with area, I also have the view of the apartment, right? So by view, what I mean is that if it's a sea view or it's a whatever view, then depending on that my price will increase, and also I will have the number of balconies. Let's say if I have two balconies of, or if I have three balconies, zero balcony, based on that also my price will vary. Now using these three variables, I will be predicting my price of the house. So such problems will come under multiple linear regression problems. Here x1 you can say is your area, x2 is your view, and x3 is your number of balconies. Let's say this is your any point 1 which is represented by, let's say, x1 and I will say y1, and this is your point 2 which is represented by, let's say, x2 and y2. I'm sorry, bear with my handwriting for now. So how will I find these m coefficients, this m1, m2, m3, or whatever coefficients of this particular variable, right? So as I can see that for x1 my coefficient is m1, so m1, m2 and m3 are the coefficient for x1, x2 and x3 variables respectively. So how will I find that particular coefficient? So this m, how we can interpret this m is, this m is basically this slope of this particular line. What do I mean by slope is that how much variation is there in my y variable with the unit change in x variable, right? So using this particular formula we can find our slope. And how we can interpret this intercept is that whenever your area, square feet area, is 0, then what is the price that we are getting when x is equals to 0, right? So if your x is equals to 0, your c will be equals to y. So that is how you can interpret your intercept. Now let's dive a bit deeper into the calculation. So now let's suppose I have this data set, right? I have area, I have number of balconies, and then I have this particular price. So this price is, let's say, my target variable, and these two are my independent variables, area and balcony. Now I can make these three equation using these three rows of my data. Now as we studied algebra in our 10th, 11th, 12th, we very well know that if we have three variables and three equations, we can find the value of these three variables, right? Now once I calculated the values of, let's say, m1, m2 and c, in future if I will get any value of area and balcony, that is your x1 and x2, I'll be very easy it will be very easy for me to find out the price of that particular house, right? Now let's say, suppose if my area is 1500 and my number of balcony is 3, I can easily found the price of my house because now I know the value of m1, m2 and c, right? It's very easy to calculate. For your practice, you can calculate this particular value and let me know in the comment section below. So now the main aim of our model is to find this best fit line. So I have so many data points here, right? I have around some 10-20 data points, and I need to find out one line which is best fitted for all these data points. Now, how do I find a best fit line for my model? This best fit line, I can make this best fit line if I know what is the value of m and what is the value of intercept c, right? So basically my aim is to find the coefficients and the intercept value. So now my main aim is to find the best fit line. So what do I mean by best fit line? So let's suppose we have some 15 to 20 data points here, and I can make a line like this or like this, right? Or maybe some another line like this. Which line is the best fit line for all these particular data points? How will I know that? Now, in order to find out the best fit line, I need to find out the parameters for those line, right? If I know the slope of this line and I know the intercept of this particular line, I will be able to plot my best fit line, right? So I basically need to know the parameters for my best fit line. If I'll know the intercept and the slope of the best fit line, I can easily plot this particular line, right? So now how do I find the best fit line? So suppose this is my actual data point, right? This is my actual value of the price. And this is what I am predicting, right? If I take into account this particular line, then this is the value that I am predicting. Similarly, this is my actual price of the house, and this is the value that I am predicting. This value is the error value, that is the difference between the actual value and the predicted value. Now, my best fit line should be such that my error is minimum. Whichever line will give me minimum error is my best fit line, right? So how do I find that error? So here, let's say I'm taking mean square error. I'll just take the difference between the predicted and the actual value. This yi is my actual value and this yi hat is my predicted value. So I'll just take the difference between these values, I'll just square it and I'll do the mean of it. That is what you mean by mean square error, right? So I need to minimize this mean square error in order to find the best fit line. Now, you might remember that in your school days, you might have studied that if you want to calculate the minimum of any particular equation, we just need to equate the derivative of that particular equation to 0, right? We used to equate the derivative of that equation to 0, and we used to find out the value of the variables where that equation will give us the minimum value. So same concept we will be applying here. Same concept is being applied in the linear regression model in machine learning. It just equates the derivative of this particular equation to 0 to find out the best fit line. So this method is known as ordinary least square method, where we find the best fit line by minimizing the difference between the actual and the predicted values. Now this method is mainly used for smaller data sets. If you have large data sets, then you should go with gradient descent problem. Gradient descent is an optimization based approach to find your parameters, your coefficients and your intercept, and this is mainly suitable for large data sets. Alright, so now that is all for this particular video. Just let me know in the comment section if you guys have any doubts or any confusion. Please do like, share and subscribe to my channel if you like this video, and I'll see you in my next video. Till then, stay safe, take care, stay inside. Bye bye.